Hello, dear students. Welcome to the channel and welcome to this playlist in which we are discussing about the instrumentation and sensors, the second chapter or second module. Up until now, we have discussed a lot about sensors, instrumentation. We have discussed about selection of the sensor. We have discussed about the setting, the installment, the basics of all these. We have discussed in detail about the operating modes of different sensors. We have seen the classification and operation of the different sensors, and today we are going to discuss a bit in detail about the selection of the sensors and the different parameters which affect it. We have already seen the basic six parameters which affect the sensor selection in previous videos. So this video is going to be the continuation of that video. If you haven't checked out that video, the link will be flashing on the top right hand side corner of your screen in the I button. So you can simply click on it and check that video out. And in case you have already started or already checked out previous video, then let's discuss this video. So here we have listed down some parameters which are important for the selection of the sensor. First one important parameter, the first important parameter will be the parameter to be monitored, right? Which parameter you want to monitor. And as we have discussed earlier as well, you cannot use the thermometer for the measurement of temperature in a semiconductor device, in the semiconductor switch, right? You have to go for some other thing. So you have to be considered, because all of them are measured for the temperature detection, but what parameter you want to measure, right? If you want to measure the temperature of a human body, you cannot fit an RTD into it. No, you have to use thermometer. So it is important that what parameter and what application that demands the measurement. Then we have the required accuracy. Let's say the requirement of accuracy will be different for different purposes. Sometimes require a lot too accurate data, and sometimes a little bit less accurate scattered data can work as well. And always remember one thing, that the as the accuracy of the sensor increases, so does the price of that sensor as well. So if you want higher accuracy, you may have to pay higher price or higher cost for that sensor as well. So you have to be very precise about how much accurate you want your sensor to be, so that you can purchase only that a sensor that offers only that much accuracy and not more than that. After that, we have the required precision, that how much detailed you want to know about the measurement. Like for example, in general cases, when we measure something, we go till the two digits after the decimal. But when you are measuring a temperature of a star, you do not go for the measurement which goes 2 points after decimal, right? Because it doesn't matter, the temperature of star would be too much, the scale is too big. So a less precision would okay in that manner as well. And same can be said about accuracy as well, right? It doesn't matter if the star's temperature is 5002 or 4998. You can call it 5000, because either ways, if you going to step on it, you are going to get burned. So precision is one more thing that goes hand in hand with accuracy. And uh, same principle for the cost applies in precision as well. If you want more precision, then you may have to pay more price. The cost will increase with the precision. So with more precise device or more precise sensor, you might have to pay higher cost, right? So I have already elaborated the relationship between accuracy, precision, and cost uh, in this video only by discussing that. And the cost, the how much budget do you have and how much you are willing to pay for that particular sensor. Just as I've said in one of the previous classes, that if I am buying a house for say like 25 lakhs, and I am spending 20 lakhs after an interior, then maybe it is too much. But if I'm buying a house for 25 lakhs and I'm spending 40 lakhs for the interior only, then it is too much, right? So it is important to select the sensor which is more suitable in the cost as well, right? If you are buying a telescope, then you might have to see what accuracy precision it provides you, and how costly it comes for, right? How much cost do you have to pay for it? Then you have to see the installation requirement, the sensor you are about to purchase or sensor which you are about to buy, if does that fits into the setup which in which you are planning it to uh, s- put or not. So you have to determine that as well. That will be the installation requirement. What happens sometimes, um, if you are aware of the vehicles in which we set up different engine parameters, we set up or check different engine parameters with the help of a device called OBD device. So sometimes you have to identify in which cars which device fits and which device does not fit. So you have to check if the installation requirements are getting satisfied or not, and would you be able to install your equipment or sensor in particular system, or will you not? And you will also have to check whether you would be able to install it permanently or would it be temporary. And based on your requirement, you may fit it on temporary basis or permanent basis. And of course, if your sensor requires some special requirements, then you might have to satisfy that as well. And special requirements may differ in the cases of different sensors, right? Like for the measurement of temperature, what would be the special requirement? The special requirement would be your sensor should not be made of a material that holds too much temperature and should have a display, right? So there are some special requirements for different sensors. Based on that, you pick your sensor. Then let's take an example of sensor designing. So if I'm designing an electrical resistance strain gauge or strain gauge, then a quarter bridge network would be required, or a half bridge network would be required, or a full bridge network would be required, based on whatever type of strain gauge that I'm making. I have to identify that, right? Same case applies in the LVDT as well. LVDT stands for linear variable differential transformer. So it is a displacement measurement device which we use, very popular one in that case as well. And then vibrating wire transducers as well. You have to identify. Then comes the important part, the sensor setting that we are going to discuss today. And it is very important because it has been asked in GTU so many times. And not only that, but the setting of your sensor is very important, because you have to identify, now you have identified the sensor, that this sensor is suitable for my system, but you have to identify the particular location where your sensor would be fitting, right? So first you have to measure the location where you would be fitting your sensor, and you would have to identify uh, would that would that volume or area would be good enough for your sensor to be uh, to adjust over there, right? And you also have to make sure that if your sensor releases some kind of heat or any other thing, then would it be enough space for that material, would it be heat or any liquid or any gas, to move out of that system more accurately without sticking up. And you also have to make sure that whatever device you are using, it it does not complexify your system, right? You have to keep your system simple. So you have to make sure it does not create a mess of wires or mess of cables or mess of any other thing. Plus you have to make sure that wherever you fit your sensor, wherever you pick the location, it is clean, and you can get the display out of that place, right? Or uh, you can see the value of the measurement at that place only, whenever you have installed your sensor. Then the second important point about the setting of the sensor would be the access. Your sensor should be accessible. For an example, if I'm taking a sensor and I'm installing it in a vehicle, let's say a car, inside the bonnet, and and remember, car bonnet has so many things around it, and sometimes what happens, it gets too less spacious, or too complex to identify the sensor that which we have placed earlier. And sometimes that sensor does not sometimes what happens, we do not place it correctly, so it does not give us output, and then you want to check it. You uh, uh, you want to check it, what happened to your sensor. So what would you do? You would go and you would try to see it, but it is not visible. You would try to place that sensor which you might think it is which has been misplaced, but it would not be accessible. You would not be able to reach towards it because of the complexity of the vehicle, because of the too many other parts covering it. So you have to make sure that wherever you have installed your sensor, you must have been you must be capable enough to see it, and you must be capable enough to identify the place where you have installed your sensor, right? So it must be accessible. Otherwise, what happens in case, sometimes in case of fault, when you know that there is a fault in this sensor only, this sensor is not working correctly, and you want to replace it, so what would you do? You will go and you would try to remove that part and replace that part, remove that sensor and replace that sensor, but it is not accessible. It has been uh, uh, it's below the pile of different instruments. So what would you do? You would remove all these instruments one by one, and then you will reach till your sensor, and then you will replace it, right? That becomes too difficult. So you have to make sure your sensor is accessible, so you don't have to clear up the pile of different uh, parts of the engine which are already working properly. So your sensor must be accessible. If your sensor is a field sensor, then its security is very important. If it is in the field, and if it is in open field, then its security becomes very important. So sometimes it is uh, sometimes what happens, if you have placed a sensor in some place, and if somebody wants to disturb the measurement of sensor, what he can do, he can misplace part or two of a sensor or your device, so that you will not be able to gain the uh, output which you are supposed to get. So the output which you will be getting will be erroneous. So what do? You have to make sure that your sensor is well secured, and you also have to make sure that the thieves don't catch it and don't steal it, right? So the security is important portion. Then there is an obstructiveness, right? If there is an obstacle which alters the reading of your sensor, which alters the uh, output of your sensor, which may cause in erroneous reading one more time. So you have to make sure there are no obstacles, there are no obstructions which affect the value of correct reading, right, of your sensor. And there are always some special requirements based on different type of sensors for the setting of the sensor, right? Like if a temperature sensor is there, then it must be able to sense the temperature, so you have to make sure that it has been installed in the correct place. Same you can say for the pressure sensor as well. If you are using a pressure sensor, so it must be placed in such place that it is more accessible to the that pressure it has to measure. So there are some special requirements based on different type of sensors, and based on that the setting of your sensor will take place. So it is very important to place your sensor or install your sensor in the right place. And then we have the case study of this campus of NCSU, right, Carolina State University, in which they have placed uh, three different sensors in three different places, right? Piezometer. Then there are two piezometers on two different locations: Farm Pond Earth Dam and then Lake uh, Raleigh Dam. Then we have inclinometer at Farm Pond Earth Dam, and then strain gauges at load frame in CFL, right? So first they have mentioned about the selection of the sensor. So they have given the right reasons for selecting inclinometer and piezometers and strain gauge, because the sensor that they have selected are commonly used in infrastructure instrumentation and thus fundamentally important for undergraduate civil engineers to learn. So that is why they are using it. What is the application of these three? So inclinometer is used to measure the ground tilt or horizontal displacement. Piezometer is used to measure the pore water pressure, and strain gauges are used to measure the strain in selected structural components. And each of these selected sensors are expected to be robust and stable for a long term monitoring, and it can be monitored remotely as well. So that is the reasoning or causality between the selection of the sensor by them. Then we have given the details of each sensor in sensor. Let's say for piezometer, so this is the model which they are using: Geocon model 4500 VW piezometer, which has outstanding long-term stability and reliability and low thermal zero shift. And here you can see the data from the data sheet of that piezometer. Then they have selected inclinometer. This is the model which they have picked, and it is designed to be left in a place inside the casing to permit automatic or continuous monitoring, right? So the strings of sensors are joined together to obtain deflection profiles, as you can see here. And here is the data for inclinometer from the data sheet. And the final one, here are some pictures of inclinometer, as you can see. So it looks like this. And the final one will be strain gauge or strain gauge, which is capable of capturing structure response to short-term live load, and it is mount to various structural members like steel, concrete, timber, and it is easy and quick to install in any weather, entirely reusable as well. That is the reasoning behind selection of strain gauge. And here's the setting of these sensors which they have used. So how did they select the sightings of particular sensors? So firstly they have seen whether the sensors are used to accommodate the desired sensor types or not. Then they've checked if these sensors are allowed easy access for installation or not. Maintenance and future class field trips are suitable or not. Then they have checked for their ability to provide interesting data that are interpretable by students which are studying them, so it should be easy enough. And they've discussed that if it allows the centralized remote data collection, logging, and storage or not. Based on that, they've selected the sighting of their sensor. And where did they sight it or sit it? So here are the places. Don't bother with it. This is the map of the university, so we wouldn't understand it either ways, right? But satellite map gives you area. This is the Relaying Dam. This is the Farm Pond Dam. This is the CFL area where they have placed the sensors. So you can see the piezometer has been placed here. The inclinometer has been placed here. This is the lake rail, and this is the farm pond. Here's the piezometer. Here's the inclinometer. This is the earthen dam. And here is the CFL in which they have cited the final sensor. Then they have installed the piezometer in the borehole. So they have established initial zero reading first. So this is the installation part that we are discussing now. So first they have established initial zero reading. Then they have saturated the filter stone. Then they have drilled the borehole and washed it to clean off cuttings. Then they've delivered the sensor down to expected level where it required to be uh, obtain the desirable output. Then they backfill with clean sand around sensors to form collection zone, and then finally they filled it with bentonite between collection zones up to the top of the borehole. So here are the selection view for the piezometer configuration in the relay dam. Then we have the sensor installation piezometer. Here's the configuration. So you can see where the sand is and where is the bentonite. So here are some pictures of them operating. Then let's come to inclinometer. Now how did they install the inclinometer? So first again they have drilled the borehole. Then they installed the casing and connected the sensors, wheels and tubing. After that they have lowered the assembly into the borehole with safety cables attached to the bottom wheel. Then they continued to add the tubing, sensors and wheel assemblies until the last sensor has been installed. And then the record zero conditions they checked after the stabilizing of the sensor, right? So it might seem less work in the slide presentation, but it requires a lot of hard work, as you can see here. Here is the selection view of inclinometer configuration in farm pond dam. Then we have the details of inclinometer configuration, and here are some pictures of sensor installation of inclinometer. And here's the installation of loading frame in CFL. Now let's discuss about the measurement. The sensor measurement or data measurement for the sensor is accompanied with a data acquisition system with wireless data transmission capability and the solar power supply as well. And what are the devices we use for the measurement? So we use the data logger and support software. Or here are the devices which they have used for the data measurement or sensor measurement. They've used a vibrating wire interface. They have used a multiplexer. They have used a radio and antenna of the radio, and then a power supply. And here are the images. How do they look? So here the data logger looks something like this. Then we have the vibrating wire interface, which looks like this. Here is the multiplexer. Here is the radio with antenna, simple, and solar panel for the power. Right. So they are using the solar panel for the power supply. And here is this software. How here's a look of the software, which looks something like this. The output signal of the VW sensor, the this one vibrating wire interface sensor, is frequency. So they get frequency in output, which can later be converted into pressure or displacement based on whatever sensor you are using. You can convert it in whatever quantity you want to, right? So they are converting it. And here are the graphs for the pore water pressure from the farm pond dam. So on the x-axis you can see date, and on the y-axis you can see the pore power pressure, and you can see the precipitation here, right? So you can see with higher precipitation, the pore power pressure in kilopascal increases. Simple observation. Here you can see the horizontal displacement as well from the farm pond dam. Not going into the details. And here is the temperature details from the farm pond dam. So this is the website from which you can access the project itself. And to summarize it and to conclude that the module, this is not, by the way, the end of the module for us. This is the end of the module for them. So this is basically a case study which we saw, which is provided in detail based on the instrumentation network setup on the North Carolina State University Centennial campus. And if you have any doubts or questions, please feel free to ask them. I will be answering them as soon as possible and as many as them possible. You guys are not asking questions, which is not very good thing. So please ask question, because without asking the question you won't be able to clear out the doubts in your head. So please ask the questions. And if you have any other feedbacks or suggestions related to the channel or videos, please mention them in the comment section below as well. If you want me to make a video on certain topic, then please mention that in the comment section as well. So I will be making video on that as well if you want to learn. So we will keep today's class till here. The module is not over, I'm repeating. It is the end of one of the important topics, but not the end of the whole module. And also, I one thing which I wanted to mention so desperately, that all this work belongs to the North Carolina State University. It's not my own work, it is work of North Carolina University. I am just stating it, I am just using it for the demonstration to you, in order to make you understand the concept in much better way. So please acknowledge that the courtesy and the copyright goes to the North Carolina University, and I thank them for uh, providing the slides, putting it online, so I can so I could teach you that. So thank you very much for to North Carolina University for making this effort. And we will keep today's class till here. Ask doubts if you have any, and next class we will discuss new topics. So one more time, thank you very much for listening. Take care of yourselves and goodbye for now. I will be seeing you in next class with a new topic. Goodbye for now.